guys, we're starting. Be quiet, please. All right, listen. Before we get into the quiz review, I just want to go over what is going to happen over the next 3.5 weeks. We have 17.5 days. Technically, we're down to 16.5 because this day's almost over, baby. Yeah. And a lot of us have a little bit of turkey brain. I know I had some turkey brain coming back to school. I was like, what are we doing? What chapter are we on? What am I teaching these kids? We all get it. It happens to teachers too. But we all have to kind of realize that we have 3.5 weeks of school. So even though we're all coming back from turkey brain, then we're going to go into like Christmas brain soon. We still need to finish this quarter strong. Right? So I want to tell you guys that we're going to go through the rest of this chapter or topic this week. And then after that, it's pretty much just reviewing. I'm not going to be teaching any new lessons after we finish this topic. This topic has 2 more lessons. That's it. Then I'm going to be spending basically the rest of these 3.5 weeks, reviewing, and we have our quarter 2 test and things like that, okay? Just give me a second, let me go through this and I'll answer questions. So I have my little sketched out, like my little calendar, my little draft. So we came back from our break, now we all have turkey brain. Today we're gonna ease back into the material. Instead of teaching you a brand new lesson today, I'm gonna be doing a review from what we did before break. And the best way to review is to take that quiz that we all took and take the data and, not take it again, but we're gonna take that quiz and we're gonna go through the data and see which question should we go over together. And it's not just because we're gonna go over the quiz, it's preparation for the topic test that's coming up, and we'll talk about that in a second. So today is going over the quiz as kind of a review, catching up, getting rid of some turkey brain, okay? Tomorrow, we have a new lesson, 4.4. It's the same stuff that we've been learning, just inequalities. And then the same thing with, that'll be a 2-day lesson, and then Thursday, we'll have our last lesson of the topic, lesson 4.5, and that is also on inequality. So it's basically graphing lines, but with inequalities, and then doing systems with inequalities. It's the same stuff we've been doing with our graphing, substitution, and elimination methods, but those last 2 lessons will be applying it to inequalities instead of equations. It's pretty much the same thing with shading added to it. So we'll go over that the rest of the week. After that, so we're gonna have no homework tonight, and then tomorrow you'll have your 4.4 homework that's due on Thursday morning. On Thursday, when we do lesson 4.5 and finish it on Friday, you're not gonna have a 4.5 homework. You'll have your practice test due Monday. On Monday, we'll have a full review of topic 4. On Tuesday, you're gonna have your topic 4 test. We don't usually have tests on Tuesdays. We usually have them on Fridays. That's our day. But I communicated with the other teachers and made sure you don't have any other tests going on Tuesday. So I'll have a review on Monday and your test on Tuesday. And that gives us plenty of time to start getting ready for the quarter 2 exam. I have 5 days on the calendar just to get ready for the quarter 2 exam. Instead of just doing 1 or 2 days of review and cramming it all in, we're gonna take 5 days. I'm gonna give you, that will be the end, whoops, my watch just thinks I'm talking to it. That will be the end of next week, starting next Wednesday. It'll be Wednesday, Thursday, and Friday. We're pretty much gonna be working on the practice test for the quarter 2 exam. We'll be working on that in class. And then the next Monday and Tuesday, we'll be reviewing everything, going over what you got wrong on the practice test. Then that Wednesday and Thursday, the 13th and 14th, will be the quarter 2 exam. On that Friday, we'll just do a little in-class activity. It'll be a project grade. You know how easy those are when we do them together. We watch the little videos, and we talk about it, and boom, it's a project grade, right? So then after that, it's just our 3-day week going into Christmas break. We're gonna keep it really simple, and we're gonna do, remember the BOY test in the beginning of the year, beginning of year test? It doesn't count, it's just for data. It doesn't go into the grade book, it's just for data. So we're gonna do our MOY, which is the middle of year test. The MOY. We did our boy. Now we're gonna do our MOY, and at the end of the year, you'll do your EOY.
Your. I got a question.
Okay. So it's pretty much the same test that you took in the beginning of the year. It's exactly the same, except they like switch the questions around, or switch the numbers, but it's not graded. So after we're done with quarter 2, we'll do a little project in the class, just in class, and then we'll do the MOY. It's a no pressure test, just for me to see, hey, did I teach you anything this year? How are you guys doing? Do you know what you're supposed to know so far? Just for me. And then that's it. And then on Wednesday we go ice skating, and then we go on Christmas break.
Are you gonna go?
So, of course, I love ice skating.
Me too.
So, yeah. So, once again, out of these 3.5 weeks, we are learning 2 new lessons. That's it. Everything else is going over stuff, reviewing. That's good news, right? Okay, so let's put all of our effort into this because we're gonna use this time wisely. It doesn't mean we're just gonna like do nothing. We did nothing for the past week, got turkey brain. Now we gotta jump back in, learn what we need to learn, review what we need to review, and just rock these tests, okay? Yeah.
3 questions. Question number 1, when is the quarterly exam? The second.
It's the 13th and 14th. It's on a Wednesday and Thursday. So it'll be 2 weeks from this Wednesday.
Okay.
And I'm gonna give you your practice test for it next week.
Second question.
Yeah.
Did you go Black Friday shopping, and what malls did you go to?
I don't go to malls ever.
What?
I did go Black Friday shopping, but only because there's this really cute like antique store called Junk Co. in Fort Ritchie.
I was really
You guys
talking
ever been
about.
there?
Yes, queen,
It's
yes.
fabulous. And I didn't really buy it. I don't go like big Black Friday shopping, but it was just for
We woke up at 4. We woke up at 2 a.m. just to go to a mall at 4 a.m.
That's crazy.
Also, last question.
Okay.
What did you do the rest of your Thanksgiving break?
I basically cooked, baked, and ate the entire break. It was really, really
You know what I did?
delicious. Yeah.
I cooked, I ran, I ate, what else did I do? I found a tree,
You found a tree. That's
and
really.
we're gonna decorate it today.
Oh,
and
a
I
Christmas tree.
ran.
I was just thinking of a regular tree. I thought it was
And I
great.
ran at 5 a.m.
You ran at 5 a.m. That is definitely something I didn't do over Thanksgiving break. Do you have a question?
It is very hot in here.
That is not a question, but I will ask maintenance to.
Your birthday.
This is got a PlayStation 5. How was your
That's not a regular. Everybody, notebooks out, notebooks open, mouths closed. We're gonna go through those questions, and I'll ask them to come up here. Hi, it's Mrs. Lake. Could you get maintenance to make it 1 degree cooler in the house? Thank you so much. Yes.
I'm not the 13, 14, 15.
Or you like this one? Okay. That's gonna be a thing for all of your classes, I think, because. Well, actually, you're really just gonna miss the math one. So you're gonna, will you be here the 19th and the 20th?
No,
Are you coming back? Yeah, Tuesday the 19th. Okay. I don't know, girl. Let's talk some other time, just because we'll have to figure out if you're gonna take your test early or later. Because that's gonna be a lot of stuff. All right, so I'm gonna go ahead and do 2, and then 6.
You're gonna do every single question?
Yeah, I feel like I wanted, okay, and then 9, 10, 11, and then possible 12. Okay, so let's do this.
for a grade.
This is not for a grade, this is just part of our easing back in from turkey brain. So notebooks open, mouths closed. Let's get it started in Ha.
What question is this?
This is number 2.
Number 2.
Oh, so tiny.
Tiny.
Okay. We have 3 methods of solving systems. They are graphing,
Elimination,
Yeah.
substitution,
Yeah.
and
Graphing.
and
Shut up,
graphing. Very good, don't say shut up.
Sorry.
Okay, so this one says solve the system of equations by graphing, so which method should we use?
Graphing.
Graphing,
Chicken.
very good, I know. Guys, I'm just easing back in from turkey brain, okay? We've gotta ask the simple questions. All right, so we have a system right here. We have 2 equations. And guess, are these equations given to us in slope-intercept form?
No.
Are you looking at the equations?
Oh.
You gotta look at the equations first, bro. Look at our equations. Are they in slope-intercept form? Up here. Can you see them?
Yeah.
He's thinking. That's how we can.
Okay.
He's using his thinking brain.
Grayson, help him out. Are these equations in slope-intercept form?
C.
C, senor, they are.
With
It's a little bit tricky
Oh.
because this one is missing what?
I was saying C as like a option. That like C
No,
as
you
a-
weren't.
Yes, I was. No.
Okay, well then how was that answering my question? I said, are they in slope-intercept form?
C,
And
all
you
the
said
above.
C.
All the above.
Okay,
So technically, you just gave the answer.
the answer is not C.
Oh, I know what that is.
Okay, can you guys pay attention? You guys are acting like crazy turkeys over here. Like, all over the classroom. Okay, all right. So this is missing, somebody said it, the what?
Y-intercept.
May I continue? Thank you. This is missing the y-intercept, so what is our y-intercept?
0.
Girls, I keep asking you guys to be quiet, and then while I'm asking one group to be quiet, another group's talking. Stop being little turkeys, going gobble, gobble, gobble all over the place, acting like crazy Thanksgiving turkeys.
Get Lex.
Okay, so our y-intercept is 0. And then over here we have our y-intercept, but our slope is kind of invisible, so what would that be? It would be 1, very good. So a good way to start on this is to make sure that you have all of the information that you need. If it doesn't look like it's there, make it appear. So our first, instead of just trying to choose a graph to match this, I'm gonna go ahead and graph it, and then match my graph to the correct graph.
How can we make things just appear and then not be able to blow them away?
Wait, what is one? Doesn't work. Try. Okay. We make it appear if it's there, but it's just not showing up.
It's
It's
there,
kind
but it's
of
not
like
there.
if you have the number 5, right? I could also write that number 5 as 5.0. Or 5.00, or 5.0000, but why would I have all of those show up when it's the whole number 5?
It's there. but
I
it's
don't
not
even
there.
need the decimal if it's a whole number 5.
It's-
So with numbers, sometimes you need things to show up, and sometimes it's fine if they're invisible.
It's there,
So-
but it's not there.
For when we're graphing, we want these things to become visible so that they help us plot our points. So somebody help me plot the points for the first line. What do we do first, Bo?
Okay, so first you gotta plot the y-intercept.
Okay, which is
0.
good. Where do I plot that?
It's just like in the middle of the line.
What do we call that?
Hold on, I got that. I got this.
Do it.
Thinking.
It's coming to him. Look, it's coming to him. It's so close. Faith, help him. The origin, very good. It was so close, on the tip of your tongue. No, it wasn't. That's why we
I
got
thought it
it.
started with C.
That's okay. So we plot the y-intercept at 0 on the y-axis, which happens to be the origin, because it's also 0 on the x-axis. I know that freaks some of you guys out when you plot a point at the origin. That's okay. If the y-intercept is 0, that point is on the origin or at the origin. Now that means the line is going to intersect the y-axis at that point, but we don't know which direction that line is going until we plot that other point. What information do we need, Vincent, from the equation that will help us plot that next point?
We need the x.
We don't need the x, we need the number that's right next to the x because it's our it's the slope.
It's okay, we all
You got turkey brain over there. Slope-intercept form means we have our slope and our y-intercept. So our slope is -5, but when we're graphing the point or plotting the point using our slope, -5 only kind of helps us do half of the work. How do we have to write this -5? Yeah. Over 1, very good. We want to write it as rise over run, which means we're going to write it as -5 over +1. And that gives us both pieces of information we need to go from this point to our next point. -5 means to go
Down 5.
down 5,
Over 1.
and then over to the right 1.
Because positive.
Let me make sure that's -1, 2, 3, 4, 5, good. And over to the right 1, so I'm just gonna connect those dots. And I've got my crazy little curvy line. Nobody's perfect, okay? That's a terrible line. But don't worry, I have a feeling it's gonna be all right. Christmas colors, red and green, that's fun. Jingle bells, all the way. What? Oh, really? Lily? This means everybody be quiet, okay? Doesn't mean finish your conversation. All right, so now I'm gonna write this in green now, because I'm gonna use green for my next line. Lex,
Yes.
will you please help us plot the points for this next line?
Yeah.
No.
All right.
You got this, like,
So the 1x, it's gonna be. Let's start with the -6.
Let's do that.
Yeah, the -6. So you go down 6 on the y-axis.
Good, because that's our y-intercept, so that would be down per,
Yeah.
okay? Then what do I do?
Then you go.
Oh no, my slope is just 1. It's not written in rise over run form.
Yeah.
Slope is 1, so that means it's what in rise over run form?
1 over 1.
1 over
1 over 1.
It's 1.
So, what direction do I
So
go?
you go up 1 and right
Up.
1.
Good. Up 1 because it's positive, and over to the right 1 because that's also positive. Oh my god!
It didn't
Intercepted right here at this very point. That means it has a solution, specifically one solution. What is the solution?
4.
Bo,
-5, 1.
close. Switch those.
Oh, 1 x.
Yeah, x is 1, so x would come first. The 1 and
One
then the
negative five.
Good. So 1 -5. So with that information, we can both find the matching graph and answer part B, which asks specifically for the coordinate pair solution. Now, right here, choice A,
Yes.
+1, -5, boom.
I got that
Choice
right.
A is correct. And then it says write the solution, so you would just write 1,
1 -5.
-5.
Time.
Do you guys understand that?
1 -5.
All right, let's go to question 6.
I've got
Okay, let's say question.
That's a bad one.
Okay, so we did graphing. Now this one's asking for substitution. Is it possible that this question is going to give us no solutions or infinitely many solutions?
Yeah.
Probably not, because it's asking for a solution and it gives you 2 places to put your x and your y value, so it's probably going to intersect and give you one solution. Is there- I really feel like you should be paying attention to to this and not this. Okay? Oh, sorry, didn't mean to drop that. Okay, so we're going to use substitution. And tell me why, hint, hint, substitution is going to be such a valuable method here. Let's raise your hand at the same time. Grayson, you started.
I just understood.
Okay,
I'm sorry.
Uriah.
I'm sorry.
It's okay. Why is substitution really going to be,
The variables are on
which one?
the
Yeah, he's noticing that one of the variables, specifically the y, is already isolated, which means it's kind of giving the answer to y. It's giving it as an expression. It's saying that y equals 3x minus 14. And if these equations are part of a system on the same coordinate plane, that means that this y is this y. So that if this y is this, then this y is also this, which means I can take this and substitute in for that.
That's some mathematician stuff right there.
I know. Boom. Okay, so I'm going to rewrite my top equation where I don't use my y variable and I just use my expression that has my x variable in it, 3x minus 14. So I'm rewriting the top equation exactly as it says, but instead of putting the y, I'm putting the expression that's the value for y.
A why?
14. Does everybody understand that?
Yes,
Yeah, I
and
do.
then after you can.
Does everybody totally understand
I just
this
Why?
part?
I couldn't remember that.
Yes?
No, I can't see it.
After him.
Okay. Now, why was it so important to use this for y instead of the variable
I
y?
don't know.
Yeah.
Because if we just times that inside the parentheses, then we could get our x, and since y is already done for us,
Yeah.
we could just.
Well, it's not like done. It's
But then we could solve for a y too.
yeah. Well, yeah. Yes, but well, I'm going to fill a small thing in there in the beginning.
Multiplication.
When we substitute the y, it's kind of like eliminating it too. It's not like gone, but it's being substituted so that now we're only dealing with x values. When you have only one variable in an equation, you can solve for that value. I can't solve for a variable if there's a whole other different variable in there. But now that I've gotten rid of the y variables and I only have x variables, I can solve for the value of x.
When you solve, can't you merge the
Merge.
x and the 2 together before distributing?
This?
Yes.
No, because they're not like terms.
Oh, that's right.
Because x is an x term, 2 is a non-x
So
term.
then you distribute first.
Yep,
Okay.
so we can multiply. You're allowed to multiply terms that are not alike, but you can't add them. So we have x is going to just stay x for now. Then we have 2 times 3x is positive 6x. 2 times negative 14 is negative 28. If you guys want to fill this in before I even say it, that'd be great. And then we have equals 14. All I did was distribute. I'm just simplifying, okay? Now I'm going to continue to simplify by doing what? I know you weren't raising your hand, but you go for it.
You combine 6x plus x
Good.
to make 7x.
Good.
Yes, queen.
And then you add 28 to both sides.
Good.
They cancel it out on the left side.
Good.
And then like you divide 7 by whatever you get.
Yep, divide by 7 or whatever. Or whatever you get when you do that addition.
And then x
So,
equals 6.
yep, very good. X equals 6. Perfect.
Shebang.
Okay. Whoa!
We're halfway there.
Oh, square on a chair.
Plug in the x value and get that y. No, sorry. Shoot. I gotta rhyme with prayer. Oh, I'll figure it out.
Hair.
Okay. Hair. Okay. Hold on. Let's keep going. We have our 6 for our x value. We plug that back in. Which equation should we use? The top equation or the bottom equation?
The
By the y.
chop.
Why?
Because the x is
Bottom.
not a thing.
I mean, technically you could use either one, right?
Bottom.
Both of them would work. But, Lily, can you pay attention to this? We're gonna use the bottom because it's already solved for y. So when you plug in your x, you just plug it in, and then you calculate your numbers. 3 times 6 is 18. 18 minus 14 is 4. So y equals 4.
I did not get that.
Technically, we're done, but what is a very important step to make check your answer? Since I used my bottom equation to solve for y, to check your answer, you should put it back into your top equation and then put x and y and make sure that it makes sense. 2 times 4 is 8. 6 plus 8 is 14. Check. Is that- Yes. Just be careful.
Maybe.
Don't knock into it.
Maybe.
All right. That was number 6. Let's do number 9.
There's no guarantees, Miss Leg. Okay, there you go. Guarantees are 100%.
Yeah. I can't hear him. Why would you continue making noise?
Canceling homework, like I was then you're gonna help me and you never can I come in?
And you never do it.
I know, I was like, ouch. I was like, remember you said you help me? You never did.
I didn't mean I was saying like I have
So rude.
It's okay. You can come in any day this week during lunch and I'll help you, okay?
Thank you.
You're so welcome.
Right.
Yes.
I want to go on
Except for Friday. I won't be here during lunch on Friday. Any day this week except for Friday. What's that? Wait till tomorrow. Two of them. You okay? You gotta go somewhere? Okay.
Yeah.
All right, so now we're solving, stop talking, solving the system using
Elimination.
the elimination method. So I'm gonna write it over here, so I have some space, plus 2y. You know how to do it?
Yep.
Oh, good.
I'm a genius.
2. Now, when I eliminate, I like things to be all set up for me like 5x and negative 5x, or negative 10x and 10x. I want it to be all ready for me to just pow, eliminate. But it's not like that. So I have to do a step. I have to do a whole step to be able to eliminate. What is that darn step that I have to do? Yeah. This is number 10, 9. What is it, Bo? What do we have to do?
Alright, you need to multiply the top equation by -2.
The top equation? Oh yeah, we could. We could. That's not the way I did in my other classes, but it's totally right, boys.
That's what I did.
All right. We could multiply this top equation by -2. Because we would get a -4y when we multiply these bad boys. And that would allow us to cancel out the positive 4y, eliminating our y term. Totally fine. Now, we will do it that way, but just in case anybody else is thinking of a different way, what's another option to eliminate?
I don't know.
Faith?
You multiply the bottom by 3.
Yeah, you can multiply the bottom equation by 3 because to cancel out the 3x or the x term, you would have to make this term a negative 3x. So 3 times negative x is a negative 3x. So we could do it that way, but I'll go with Bo's way because he answered first. So both ways will work,
Where'd you get
but
that 2 from?
-2. He noticed that he could cancel out the 4y by turning this into a negative 4y.
But how?
Because if you multiply 2y times -2,
Yeah, but then where'd you get the 2 from to multiply it?
this,
Yeah.
we get to choose what number, any number that we want.
So you just get to choose any random number?
Yes, and
Okay.
the reason
I'm
that
getting
that's, it's the reason that that's okay to just make up whatever number is because as long as you do that same thing to every term in the equation, it keeps it true. When we learned this lesson, I gave you guys an example like 2 plus 3 equals 5. And I said if we multiply every part of that equation by the same thing, it would be 4 plus 6 equals 10, and it's still true, right? That's why we're allowed to just make up a number. If I change this to 3, I get 6 plus 9 equals 15. Still true, right? That's why we're allowed to just choose any number we want, whatever is going to make it work to eliminate a term. It doesn't matter if you eliminate your x or if you eliminate your y. We want to eliminate one of them so we can solve for the other. And then we'll plug that one in and we'll finish it. So for now, we're going to do Beau's way. And we're multiplying times -2. So that would, down here, that would be a -6x. And then a -4y. Whoops. -4y. And then a -44. Okay. So now I'm left with these two equations, because this one was just kind of expanded, right? So I have my positive 4y and my -4y. Vincent, what's that?
I don't know. Would it have also been okay if I multiplied the bottom one times 3?
So we just went through that entire thing. I erased this. I put parentheses on this and wrote 3, and I explained that that was the other way that you could solve it.
Oh.
Okay, so the answer is yes, and the other part of my answer is make sure you're paying attention, because you missed that part, okay? It's all right though. There are 2 ways to set this up. This way allows us to eliminate our y term. A positive 4y and a -4y cancel out. So we have a -x and a -6x, which would be -7x equals what? -42, stop doing that, it's which way. Divide by -7, divide by -7, and we get x equals 6.
We're halfway there.
I was just about to start singing, I took a deep breath. All right, we're halfway there. We have to take our x value, plug it back in. Doesn't matter which equation we use.
The first one.
Neither one is really that exciting, so yeah, we'll plug it into the first one. 3 times 6 plus 2y equals 22. 3 times 6 is 18, plus 2y is 22. Should write that down here. 18 plus 2y equals 22. Subtract 18. Am I doing this right?
Yes.
Okay, just making sure.
Indubitably so.
Do. Okay, minus 18.
4.
Oh, I know why it looks weird. Because I did it the other way in my last class and I don't remember it looking like this. Okay, so 2y equals 4. Divide by 2. Divide by 2. And I get y equals
2.
2.
No dose.
Dose. Okay, since I used my top equation to find my other variable, I'll use my bottom equation to check. Okay, -x would be -6 plus 4 times y, which is 4 times 2, equals 2. Just make sure that's true. -x plus 8, is it positive 2?
I don't know.
-6 plus 8, is that positive 2?
Yes.
That is positive 2, so it's true. Okay?
We are done.
We are the champions. I hate when it just doesn't show the question.
It does, you have to do it.
No, it doesn't.
It doesn't.
It doesn't. Okay. I have to like go to another question and go back.
It's really a, this is like,
Yeah.
the wrong with like.
I
What?
already know
It's
it.
something wrong with like.
You okay?
Just gotta do the dig along a big ball.
Oh, okay.
Take a day off, guys.
I need it.
Come back,
Lexington, done.
girls. Which statement is true of the system of equations? This is just a different way of saying solve this system. When you solve a system, you're gonna use one of your methods. When you get your solution, you'll either get an ordered pair, or you'll get no solution, or you'll get infinitely many. Which one is it gonna be? Let's find out. It doesn't say which method to use. Okay.
Wait.
4x minus 5, this is 10, 5y equals 4, 2x plus 3y equals 2. Okay, if we can use any three methods we want, somebody suggested elimination, I think that's definitely a good method to use here. But it's not set up perfectly for elimination. We have to do some finagling.
Bottom times 2x.
It's 2x.
Bottom times 2
plus
2.
Negative 2.
Just 2.
Just 2y equals 2.
negative 2. Stop. So, yes, we're gonna multiply the bottom. We want it to match this term, but of course be the opposite sign so that they cancel out when you combine them, boys. Okay? We're going to multiply times a negative 2 because we want the 2x to turn into a negative 4x. And I would say that's probably really the only way you're gonna wanna, the only choice for this one. Doing it a different way would mean you would have to multiply both numbers, and that would be both equations, that would be weird. So, possible, but weird, and unnecessary. So we have negative 4x, and we have negative 2 times positive 3y, which is, why do I have to do all the math? Negative
Why
what?
not? Because you're the math teacher.
2y.
You're the teacher. You're
Negative
teaching
2
us.
times
Oh,
3y.
negative 6y.
Negative 6y equals,
Negative 4.
good, thank you, that's the way it should be. Okay. What? No, no more bathroom. You have 7 minutes and then you can use the bathroom in the building, okay?
7 minutes. You can hold it in. You can hold it.
Stop using the bathroom during my class, it's too interesting to visit.
Yeah, math is too interesting.
This is
guys.
my,
Come on, be
stop
better.
using the bathroom
Do
right
it.
now,
Be better,
my
Miss
interesting
Johnson.
class.
Miss
Stop talking, let me finish this. I've rewritten this equation, so what I'm combining now is this term with this term. Oh, look, it's going to be eliminated. Bye. We're not even halfway there.
I know. I want to see
Negative
you
5y plus negative 6y is
Negative 1.
Negative 11.
negative 11y. 4 plus negative 4 is
0.
0. Make sure you don't
There's
go,
no solution.
but it cancels out. Hold on. But it cancels out. Yeah, it does. But when it's by itself on the side of the equal sign, you have to show the canceling out with a value of 0. Divide by negative 11. Divide by negative 11. Y equals
What?
0.
What?
0 divided by, hold on. 0 divided by negative 11 is 0. 0 divided by positive 11 is 0. 0 divided by 25 is 0. 0 divided by negative a million is 0, right? So y equals 0. That is a value. The only option that has that is choice B. Now, just because I want to double check, I'm going to take my 0 for my y. And, okay, whoa, we're halfway there. All right. So we take our y, which is 0, and plug it into one of these bad boys. I'll do 4x minus 5 times, too loud. 5 times 0 equals 4. That means 4x, this just multiplies to get 0. 4x equals 4. Divide by 4, divide by 4, and x equals
1.
1. The solution is 1, 0.
1L.
Now, this next question got a lot of people all confuzzled. Okay?
Confuzzled.
Where do we hit into Quiddy?
You got so confused, and I'll show you why.
This is the only one I got right.
What?
No, not really. I actually did good on it.
That's one.
I'm surprised.
I said what, but I got 1.6. Am I the only one?
Girls in the back, I don't know what you're doing, just focus on this, okay? What statement is true of the system of equations? So it's a very similar question. Let's see what the answer is. What method should we use?
Elimination.
Elimination. Sounds good to me.
It's like,
Yeah.
can you times the bottom by those?
Yes, I think that would be the way to go. For both, right? Are you? Do you see what I see? Said the X turn to the little
I really
Y.
I'm blind.
Stop, you're making me
Did you hear what he said?
It's so cheesy.
He
What?
said he.
I said, how offensive, I'm blind.
Oh my gosh. Okay.
Yeah, you're blind. No.
Is anybody seeing what I'm seeing?
No.
What's gonna happen?
It's shapes.
What's gonna happen?
The equal the n number and the x number is gonna disappear.
Oh, wow.
Yeah, everything's gonna disappear.
Except for the y.
Everything's gonna cancel out. Look, this becomes a negative 6x. This becomes a negative 8y. And this, is there an echo in here? And this becomes a negative 30. Hey! Hey! That means everything's gonna cancel out.
Yay!
And then all of you
Wait.
turkey brains go, all of you go, hey, and then everything cancels out. There must be no solution.
It's C.
What if you negative
It's
2?
not no solution.
What?
If everything cancels out to 0, that means 0 equals 0.
No solution.
That's an identity. An identity. Just like 5 equals 5, or 10 equals 10, or negative 16.3 equals negative 16.3.
Zero. It's no solution.
Infinitely many.
0
That
equals
means
0.
no solution.
That's an identity.
Is it-
An identity means
Infinitely many solutions.
infinitely many solutions.
But it doesn't zero means zero.
No solution would be if it said 0 equals 1, or 0 equals 10, or
Something that isn't
16
true.
equals 0.
It's
If
a-
it's something that's not true, then it would have no solution. But since this statement is true, it has infinitely many, which means these two lines, as different as they may look, they're the same line.
No.
Bread and butter? Just like.
What if 1 0 1's negative 0?
All right, that is all, stop it. That is all for today.